So hello guys, now we will see the algorithms to delete a node from doubly linked list. So in our earlier video, in our previous video, I have explained the steps for deleting a node from doubly linked list. Now in this video, we will write the algorithms. Okay. So since there are three choices or three cases that we will delete the first node, we will see the algorithm to delete a first node, then we will discuss algorithm to delete the last node, and then delete a node from any position. So first we will be writing the algorithms to delete the first node. So this is the structure that I have declared to by which linked list all the nodes of a linked list are represented. There must be an info part and there are two pointer fields. Now name of my algorithm is del head. Del head means delete the first node. You can call it del head or you can call it del first, whatever you want. Now to represent the linked list, we need two pointer variable. One is head as well as tail. But here, since I am deleting the first node, the parameter that we should pass to this algorithm is struct node asterisk start. So, or you can call it head also. Okay. So this will contain address of the first node. So start means to represent the which is the starting node or which is the head node. Okay. Now begin. So this is the mark of the beginning of algorithm. We know that in deletion algorithm, the first step is to verify the underflow condition. So we'll write the condition for underflow, that is if start equals null. So this is the case for underflow. Okay, when the start is null, then there is no node, so we can quit. So we will give a message print underflow, then we will write exit. So this is end if. Now then we'll move, if this is false, then only we can move to this particular position. So when the start is not null, this condition is false, we'll jump here. Now from here we'll try to do the remaining steps. So now second step is to reach out for the node that you want to delete. Now since I am interested in deleting the first node, so I will set ptr equal to start. So the variable ptr now contain the address of the first node. Okay, now what? Now I'll use a temporary variable item where we will store ptr of info. So the information part is now stored in the variable item. Okay, now what? Now I told you that after you do that, you need to perform some necessary pointer adjustment. Now in deletion, we always have to perform two pointer variable to change. We always have to change two pointer variable. Okay, so in my earlier video I explained that, see, if I have to conduct deletion of the first node, this is my first node, so what are the pointer that I need to change? I need to change the previous field of the second node. This is my second node, its previous field containing address of the first node. But now after the first node will be removed, there will be no previous node, so its previous field should be 0. And one more pointer variable, the variable head, or you can call it start, that should be updated to point to this node. So these are the two pointers that I need to perform, I need to change. So I can simply write, now I can write start equals ptr of next. So ptr is my first node and its next means the second node. The address of the second node now is stored in start, and then I can write start previous field of the first node, now start node, should contains null. Okay, so these are the two changes that I must perform. And finally free ptr. Free means destroy the memory space which is allocated for that particular node, that will be removed, and then I will write at the end return item. So my algorithm finished. So this is the algorithm to remove a node from the beginning. Now let us discuss the algorithm to remove a node from the end. Okay, see, deleting last node. So likewise delete tail. So I will use begin. So these are the structure, struct node, and since I am removing the last node, so instead of start, the tail should be passed. Okay, tail means end pointer which points to the last node. Now Again I'll check for underflow. Here the underflow condition is if tail equals null. So if the pointer variable contains null, then there is no node. So I can print underflow and then I can perform exit. Now end if. Okay, suppose there is no underflow, then what to do? So definitely in the next step we have to reach out to the node that we want to remove, and its address should be stored in a ptr. So I can simply write ptr equal to tail. So now the variable ptr is now pointing to the last node. So the address of the last node is in ptr. Now again I will use item equals ptr of info. Okay, so the value stored in that information part is now stored in a temporary variable item. Now again after this we need to perform changes in two pointer variables. So two changes has to be done in order to remove the link, in order to remove that node. Now let's see the diagram once again. Now suppose this is my last node, okay, and its address is now stored in ptr. Okay, now if I want to remove this node, what shall I do? Now its address is now in ptr. Let's say ptr contains the address. Now first of all I have to find out which is the previous nodes. So the previous of this node can be obtained by from this address, from the previous field. So this one, and its address will now stored in tail. So first I have to perform that. Okay, store the previous address of the previous node in the variable tail. So how can I write it? I can simply write tail equals ptr of previous. Okay, now that is being stored. So now tail is updated. Now this one becomes my last node, but the next field of this node should contain null. And okay, so I should simply update next field of the tail as null. Over. Okay, so the link has been now broken. Finally I will write free ptr. So free ptr means the memory space is released, and then return item. So I will write end. So this is the algorithm to delete the last node. Okay, hope you understood. Now the final one, that will tell me how to remove a node from any position. Okay, see, deleting from any position. So here del underscore position, the struct node asterisk head, or you can call it start, and we need extra parameter that is called p. P means position, which could be 2, 3, 4, any node number. So I have to remove that node. Now here again I need to perform verification of underflow. Now when you are removing a node from any position, for underflow condition you need either head or you can check for tail. So here I have passed head, so I will check if head means starting node, address of the first node is equals to null. So if address of the first node, the pointer variable, contains null, then there is no node. So we say underflow, print underflow and exit. Okay, and if now when there is no underflow, then I have to reach to the node which is at the given position. Now for that I need to perform a traversing. So how I can perform traversing? I will say ptr equal to head. So now in ptr address of the first node is present. Now give a comma here. Take a counter variable ctr equals to 1. So this is my counter variable. Now I am at the first node. Now from first node I will reach out to position P. So how can we do that? So I will use a loop while ctr means counter not equals to P. P means position. As long as the variable counter is not equal to position, so keep updating ptr. So ptr equal to ptr of next and increment counter variables. Okay, so end while. Now when this loop will complete, okay, so clear, then when this counter variable becomes equal to p, this condition become false and I will jump. Now variable ptr will point to the desired node that I want to remove. Okay, so let us assume in this diagram, let us assume that I want to remove the third node, and using this particular traversal loop, my variable ptr now points to the address 300, which is the third node. Okay, so now its info part must be stored in a variable. So I'll write item equals to ptr of info. Okay, so now what? Now I need to perform again changes in two address field, so that I have to remove this particular node from the link. So for this purpose I need to modify two fields. Okay, I need to modify next field of previous of ptr. If this is ptr, I need to modify this field. And what is this one? It is called next field of previous of ptr. Okay, this is previous of ptr, and its next field should be changed with what value it should contain? It should contain the address of next of ptr. So next of ptr this. Okay, so next field of previous ptr. So how can I write it? I write ptr of previous, its next. So now I will read it. Next field of previous ptr is equal to ptr of next. So now ptr of next is stored here. Okay, so this value is updated. Okay, next field of previous ptr is now updated with ptr of next. Now what value I have to change? I have to change again. Now this one. Now this one is previous field. This is called previous field of ptr next. This is ptr next. Right now this is ptr next is this one, and its previous field should be updated with previous of ptr. This one is previous of ptr. So how can I write it? Now ptr of next and its previous field should be updated with ptr of previous. Okay, should be updated with ptr of previous. Now by using these two statements, I can break this link. I can remove this node from, I can break the link that is being established. Now instead, now this link will, new links are created. So now this link is being broken. Okay, now once ptr is, the link to the ptr is broken, I can simply destroy, means free ptr, and once ptr is freed, I'll write return item. So return item means this will let you know that what was the item present in the node which has been removed. Okay, so this is the steps. And finally, for begin statement, you will put an end mark, so which marks the end of the algorithm. Okay, so guys, this is what the deletion algorithm in doubly linked list. Okay, I hope you understood this completely. So this is the algorithm, complete algorithm. Okay, so in our next video we will explore some more topic, some applications of linked list, etc. Until then, goodbye.